All right, welcome to Chapter 5, Section 6. We're going to be learning about inequalities in one triangle, and you might guess soon after this we'll be learning about inequalities in two triangles. So there's things we can set up with inequalities in triangles, and there's special relationships. It's things like if you have a triangle and an exterior angle, that this angle will be bigger than this angle or this angle. We can guarantee that that will always be true. Or another thing we'll learn is that if you have a triangle with a small side and a big side, that if this is the biggest angle in the triangle, then we can guarantee that this is the longest side, and if this is the smallest angle, then this is the smallest side. So those are inequality type situations. We're going to look closely at those, how we use them in proofs, and how we apply them to solve different types of problems. First thing, and I just mentioned this, this is called the corollary to the exterior angle theorem, which says that angle 1 will be bigger than angle 3 or angle 2, right? So angle 1 is greater than angle 2, angle 1 is greater than angle 3. Angle 1 is the exterior angle there. This is the corollary to the triangle exterior angle theorem. The triangle exterior angle theorem said that in a triangle, this exterior angle, I guess I'll call this 4 because we already use 1, 2, and 3. But this exterior angle, if we call this 5 and 6, is equal to 5 plus 6. That's the exterior angle theorem, is that 4 equals 5 plus 6. And the corollary is that that exterior angle is bigger than either of those two, which makes sense. This should be angle 4 equals angle 5 plus angle 6. Or measure, there should be m's in there. All right, so let's look at how we use that. So let's apply the corollary. In the figure at the right, what they want us to prove is that measure of angle 2 is greater than measure of angle 3. And there's a couple steps to this. So I'll go through it in a 2-column proof here. I'll give my statements and my reasons. Make sure that you take your time and understand this. This one is a bit, there's a few steps to it. So pause the video, think about it, make sure it makes sense to you. My first statement is going to be that triangle ABC, and this isn't, when they tell you measure angle 2, measure angle 3, you might not notice that this is where you need to go at first. But triangle ABC, this one, is isosceles. It's number one. And the reason for that is it's given. You can see they've marked those sides congruent. They've marked that CB, line segment CB is congruent to line segment DC. Because of that, I can say that angle 1 is congruent to angle 2. And the reason for that is they are the base angles of an isosceles triangle. Number 3, let's see, now I know they're congruent. Well, what we just learned, the corollary of the triangle exterior angle theorem, tells me that angle 1 is greater than angle 3. Exterior angle, it's greater than this one or this one, but I'm only concerned with angle 3 right now. So angle 1 is greater than angle 3, and my reason for that is the corollary to triangle exterior angle theorem. And finally, I can say that because I know 1 and 2 are congruent, I can substitute 2 in for 1. So I can switch those out. They're congruent. So angle 2 is greater than, or I always forget to write my M's. Measure of angle 2 is greater than measure of angle 3. We are writing inequalities and angle symbols now, so it's important that your angle symbols really kind of look like a L, and your inequalities look like that. They're pretty similar looking, so be careful with those. And my reason for number 4 is substitution. Property of equality. Okay, so take your time, make sure that you understand what I did there and how I got it. On the next slide, or I'll put this into the next few slides, but the next thing after you look through those is you're going to answer this question. Same picture, why is measure of angle 5 greater than measure of angle C? So 5 is this exterior one, C is this angle. It's the vertex angle of the isosceles triangle. So, there's a lot of triangles here. There's more than 2. There's also a big one, so you'll want to look at that. Write out your proof. It's totally cool to write it on paper and load in the picture. Good luck with that. I'll see you for the next problem type.